Application of hyperspectrum in remote sensing technology. The rise of hyperspectral remote sensing technology is one of the major achievements in the development of remote sensing technology in the 1980s. As the current frontier technology of remote sensing, hyperspectral remote sensing has great advantages in spectral resolution. With the maturity of hyperspectral remote sensing technology, its application fields are also increasingly extensive. This paper mainly describes the characteristics and main applications of hyperspectral remote sensing. Hyperspectral remote sensing is a technology that uses an imaging spectrometer to obtain many very narrow spectral continuous image data in the visible, near-infrared, mid-infrared, and thermal infrared bands of the electromagnetic spectrum. Characteristics of hyperspectral remote sensing. 1. There are many bands and narrow band width. The imaging spectrometer has dozens or even hundreds of bands in the visible and near-infrared spectral regions. Compared with traditional remote sensing, the imaging spectrometer with high spectral resolution provides a very narrow, generally 10 nanometers, imaging band for each imaging pixel. Compared with multispectral remote sensing, the number of bands is greatly increased. The number of bands can reach tens to hundreds in the visible and near-infrared bands, and is continuously distributed in a certain spectral range. This is not only a simple increase in the number, but also an increase in the amount of spatial information about the ground object spectrum. 2. Wide spectral response range and high spectral resolution. The electromagnetic wavelength of the imaging spectrometer extends from visible light to near-infrared, and even to mid-infrared. 5. The sampling interval of imaging spectrometer is small, and the spectral resolution reaches nanometer level, generally about 10 nanometers. The fine spectral resolution reflects the fine characteristics of the ground object spectrum. 3. It can provide spatial domain information and spectral domain information, namely spectral image integration, and the spectral curve obtained by the imaging spectrometer can be compared with the spectral curve of similar ground objects measured on the ground. In imaging hyperspectral remote sensing, a coordinate system is established with wavelength as the horizontal axis and gray value as the vertical axis, so that each pixel in the hyperspectral image can produce a complete and continuous spectral curve at the gray value of each channel, which is called spectral image integration. 4. Large amount of data and redundant information. There are many bands of hyperspectral data, and the amount of data is huge. Moreover, due to the high correlation of adjacent bands, the information redundancy increases. 5. There are many data description models and the analysis is more flexible. Hyperspectral images usually have 3 description models: image model, spectral model, and feature model. Advantages of hyperspectral remote sensing. With the improvement of spectral resolution of hyperspectral remote sensing, the ability to detect the attribute information of ground objects has been enhanced. Therefore, compared with panchromatic and multispectral remote sensing, hyperspectral remote sensing has the following significant advantages. 1. It contains nearly continuous spectral information of ground objects. After spectral reflectance reconstruction, hyperspectral images can obtain approximately continuous spectral reflectance curves of ground objects, which match with the measured values on the ground, and apply the spectral analysis model of laboratory ground objects to the remote sensing process. 2. The recognition ability of surface cover has been greatly improved. Hyperspectral data can detect substances with diagnostic spectral absorption characteristics, and accurately distinguish the types of surface vegetation cover, road pavement materials, etc. 3. The classification and recognition methods of terrain features are flexible and diverse. Image classification can use various pattern recognition methods, such as Bayesian discrimination, decision tree, neural network, support vector machine, etc., and can also use spectral matching methods based on ground object spectral database. The classification and recognition features can be either spectral diagnosis features or feature selection and extraction. 4. The quantitative or semi-quantitative classification and recognition of terrain elements becomes possible. In hyperspectral images, the state parameters of various ground objects can be estimated to improve the accuracy and reliability of remote sensing high-quantitative analysis. Application fields of hyperspectral remote sensing. 1. Application in vegetation and ecological research. Hyperspectral remote sensing can provide high spectral resolution of each pixel of the image, so that some substances that cannot be detected in conventional broadband remote sensing can be detected in hyperspectral remote sensing. Hyperspectral remote sensing data can accurately estimate the biophysical and biochemical parameters in the process of key ecosystems, especially the precise retrieval of canopy water, vegetation dry matter, and soil biochemical parameters on a large scale, which has broad application prospects in ecological research. 7. In terms of ecosystem, hyperspectral remote sensing should also be used for gradient mapping of ecological environment, extraction of photosynthetic pigment content, extraction of vegetation dry matter information, monitoring of vegetation biodiversity, inversion of soil attributes, fine mapping of vegetation and land cover, dynamic monitoring of land use, mineral distribution survey, water eutrophication detection, air pollutant monitoring, vegetation coverage and biomass survey, geological disaster assessment, etc. In addition, the emergence of hyperspectrum makes remote sensing estimation of plant chemical components possible. 2. Application in atmospheric science research. Hyperspectral remote sensing has a very high spectral resolution. It can not only detect more detailed ground object information from conventional remote sensing, but also detect more detailed atmospheric absorption characteristics. The molecular and particle components of the atmosphere are strongly reflected in the reflection spectrum band and can be monitored by hyperspectral instruments. The prominent applications of hyperspectral remote sensing technology in atmospheric research are cloud cover mapping, cloud top height, and cloud state parameter estimation, atmospheric water vapor content and distribution estimation, aerosol content estimation, and atmospheric optical characteristics evaluation. Using hyperspectral data can improve the accuracy and reliability of weather forecast and disaster warning on the basis of accurate detection of atmospheric composition. 3. Application in geology and mineral resources. Regional geological mapping and mineral exploration are one of the main application fields of hyperspectral technology, and also the most successful application field of hyperspectral remote sensing. Since the 1980s, hyperspectral remote sensing has been widely used in the investigation of geology, mineral resources, and related environment. Research in the past 15 years has shown that hyperspectral remote sensing can make significant contributions to the development of geological applications, especially in mineral identification and mapping, lithology mapping, mineral resources exploration, mining environmental monitoring, mine ecological restoration and evaluation, etc. 8. The main reason why hyperspectral remote sensing can be successfully applied in the geological field is that hyperspectral remote sensing has many different properties from broadband remote sensing. The diagnostic spectral characteristics displayed on the electromagnetic spectrum of various minerals and rocks can help people identify different mineral components, and the hyperspectral data can reflect such diagnostic spectral characteristics. With the continuous expansion and deepening of hyperspectral remote sensing geological applications, hyperspectral remote sensing technology and methods are also improving. In recent years, outstanding progress has been made in fine mineral identification based on hyperspectral data, inversion of geological environment information from hyperspectral images, and planetary geological exploration based on hyperspectral remote sensing. Hyperspectral remote sensing is also applied to the detection of geological genetic environment, altered minerals and mineralized zones, mineralization prediction, lithology identification and classification, oil and gas resources and disaster detection, hyperspectral vegetation heavy metal pollution detection, etc. 4. Application in marine research. With the development of science and technology, hyperspectral remote sensing has become the frontier of ocean remote sensing. Due to the advantages of wide spectral coverage, high resolution and multiple bands, the medium resolution imaging spectrometer has become an effective detection tool for ocean color and water temperature. It can be used not only for the detection of chlorophyll concentration, suspended sediment content, some pollutants and surface water temperature in seawater, but also for the detection of sea ice and coastal zone. The basic research of marine remote sensing application in China is mainly the construction of some mathematical models. The research on how to solve the problems such as the low reflectivity of water body and the scattering effect of the atmosphere on the blue-violet spectrum has not been involved. In the application of marine water quality monitoring, only visible light spectrum can observe underwater conditions. In addition, research on spectral characteristics of typical coastal zone elements such as land-based pollution, mariculture, and mudflat is also being carried out. Researchers use aerial hyperspectral images as data sources, select land-based pollution, mariculture, and mudflat as monitoring elements, and conduct spectral band sensitivity research on the above elements to try to obtain the best band for their detection, and further develop accurate and rapid identification and detection technologies. Stay. Relevant research has been carried out on the measurement of ocean surface temperature, qualitative or semi-quantitative observation of suspended sediment concentration in the ocean surface, and the study of ocean dynamic phenomena. The main research carried out in the world is the study of the left flux of the ocean to understand its control mechanism and change law, study on the relationship between marine ecosystem and physical properties of mixed layer, coastal environmental monitoring, and management. 5. Application in agriculture. The emergence of spectral remote sensing technology has expanded the new field of remote sensing information acquisition, and gradually become one of the important cutting-edge technical means of agricultural sensing application. In the application of agricultural migration, make full use of the advantages of spectral map integration can accurately monitor crop growth and serve precision agriculture, especially in crop growth assessment, disaster monitoring, and agricultural management. Use hyperspectral whisker sensitivity. It can accurately reflect the spectral characteristics of field crops and spectral differences between crops, and more accurately obtain some agronomic information, such as crop water content, chlorophyll content, leaf surface. The product index, LAI, and other ecological and physical parameters can easily predict the growth and yield of crops. At present, great progress has been made in the research of hyperspectral telepathy technology in the application of agricultural telepathy, mainly including the following aspects: spectral characteristics of crop leaves, crop classification and recognition, inversion and extraction of physical and ecological parameters, diagnosis and monitoring of crop nutrients, monitoring of crop growth, and yield prediction, research on agricultural and remote sensing information models, and monitoring of agricultural disaster books. With the deepening of precision agriculture research, and the continuous improvement of spectral resolution and spatial resolution of hyperspectral sensing, the application of hyperspectral sensing in agriculture will move from theory to business operation, especially simple and practical hyperspectrologists. The design and promotion of agricultural monitoring models will become a major development direction. 6. Application in other fields. Hyperspectrum is also widely used in other fields. For example, the development of hyperspectral migration sensing makes people have the ability to conduct in-depth research on the spectral characteristics of urban surface features. We have carried out a series of in-depth analysis of urban spectra with experimental training spectra, ground feature spectra, hyperspectral remote sensors for aviation and aerospace. The research contents include the spectral characteristics of urban features, and separability provides the basis for remote sensing analysis and mapping of urban environment. Some researchers used hyperspectral data combined with spectral detection algorithm to study the classification of urban ground objects. In the military field, the most advanced technology, the military application of hyperspectral image mainly focuses on the two targets, the offshore environment monitoring, camouflage and anti-camouflage, and the evaluation of strike effect. In terms of soil quality information monitoring, hyperspectral remote sensing is mainly used to obtain soil quality information, such as the reflectance spectrum characteristics of soil organic matter, the relationship between soil pond water and soil reflectance spectrum, and soil spectral reflection characteristics of iron oxide, etc. Through quantitative analysis of soil physical and chemical properties and soil fine spectral information, soil characteristic parameters are evaluated. Spectral transition sensing has been widely studied by researchers at home and abroad due to its high spectral resolution and spectral integration. The imaging spectrometer and other hardware, as well as the image processing system and other software, have achieved rapid development. For more than 20 years from the 1980s to the present, although the development history of spectral neck feeling is only about 10 years, it has been more and more widely used in many countries and fields. At present, it is mainly used in vegetation ecology, atmosphere, geology, ocean, agriculture, and other fields. Up to now, the commonly used imaging spectrometers at home and abroad are mainly airborne. To enter the practical stage, it is necessary to shift from aerial telepathy to satellite telepathy. Therefore, the future will carry higher. The satellites of the spectral and spatial resolution imaging spectrometer will be launched in succession. At present, for hyperspectral remote sensing applications, accurate classification, recognition, and feature information extraction of ground objects are developed. For the purpose of hyperspectral adaptive information processing and denier analysis model, the automation and intelligence level of spectral data processing, develop special hyperspectral remote sensing data processing and analysis. Software system and ground object spectral database are still the main tasks of hyperspectral sensing research, aiming to apply hyperspectral remote sensing more accurately to more and wider fields.